Okay, so I'm extremely bored and I don't often make videos or pretty much ever, but um, I'm gonna steal one from Frame Chasers, and I really like this kind of format where you just have like Notepad open and then just typing some random stuff. So basically, this video I'm going to elaborate on how to tune your Alder Lake system for daily stability, or at least how I did it. I use DDR5, but I did tune my friend's DDR4 system as well. So I will give you some inputs there. I've still got to work on another friend's system who's having a bit of an issue with the Eurus D4 board. So I might make something about that later on. I'm not sure what's causing his problems. I have an idea. I have a rough idea, but I'll elaborate on that as well. Um, but so let's just get to the first little bit that we have to kind of set as a base for us. So the first most important thing is this. Now, it's more so with DDR5 than DDR4. DDR5 right now, from what people are saying, and from some people I've spoken to on various discords, the chips that are in our current DDR5 aren't exactly binned, so they aren't exactly the best DDR5 that is right now, or that exists right now. Mostly because of manufacturing, just like the fact that the node has matured, like the nodes for the different manufacturers has matured. But also, I'm assuming there's another reason. I don't exactly know why. Apparently, the Hynix M die on DDR5 is actually not really. They aren't really like binned differently. Like they have different SKUs of manufacturers, yes, but overall they all kind of overclock and end up the same, more or less. So that's neither here nor there. But the most important thing to remember is this. So with regards to QVL, I can't exactly say if Alder Lake's IMC is strong or weak. I don't think I can really make that assessment because I haven't done enough testing or used enough like CPU architectures to determine this. But what I can say from experience is that even overclocking my friend's DDR4 and Alder Lake, so like for some other reason, training memory on Alder Lake seems to be particularly hard. Especially if you're talking about DDR5, but let's get to that in a bit. So for DDR4, even it seems that training memory on Alder Lake just is way, way, way harder than with DDR5, or sorry, with Comet Lake, so with previous generations as well. I have no idea why. It's kind of funny how it's hard for you to even get like gear 1 4000. I mean, I guess Rocket Lake you couldn't do more than like 37 33, so it makes you kind of think, well, it makes sense that it shouldn't be that easy to get gear 1 stable at like 4000 on Alder Lake either. But I don't know. I have no idea how Intel designed the IMC. I don't do electrical engineering. I mean, not that you could get the documentation regardless, even if you did. They wouldn't give it to you. They wouldn't explain to you how the IMC works or whatever. I've looked for it. They don't give you enough for the public, I don't think. If someone has documentation that watches this video that would like to share, like where you can read about the IMC and about the voltage tolerances and the silicon and all that stuff, like please share, because fuck, I have no idea. But yeah, like DDR4 and Alder Lake seems to like 37, 33, gear 1, 3800. That's pretty easy to do. 3900 is doable for a lot of people. But yeah, so very last thing. And it's easy to see why. If I can even just, because well, it's nice I can actually just go do this now because we have a screen recording. So if I just practically show you a QVL for something like this, which is a pretty high end board, with the reasonably good topology. But even here, you can see if I go to, it should be, actually, there we go, support list. So if I give you capacity, so let's say 16 gig DIMMs, because okay, so first off, important, do not buy. So what does this mean? What does this mean? It means why have X8, or I guess X16, sorry. So you want to have X8 on your RAM. That's always been a thing. You want to have X8 in DDR4 and DDR5. I don't know about X4. I think that's more server, but X8 is what you want, like as a normal consumer. So as a consumer, you'll want X8, and the reason for this is, to put it simply, if you have X8, you have a single, you'll have a kit of 2 DIMMs that'll have 1 rank, and if you have a dual rank kit, with X8 you'll have dual rank on 2 DIMMs if they're on double sides, or if you have 4 sticks of single rank stick, or 4 sticks of single sided DIMMs with X8 chips, you'll have 2 ranks as well. And generally, that's what you've always wanted on consumer for. I guess I don't know about DDR3 days, because I didn't use DDR3 too often. Oh, sorry, too much, because I bought PCs from like 2015 onwards. So I assume it worked the same, because DDR3 and DDR4 weren't really much different. But basically, X8 chips means 2x8 gigabyte kit equals 1 rank. 2x16 kit, double-sided DIMMs. So chips or ICs equals 2 ranks. And then obviously it's 4x8. You can only have single-sided DIMMs, obviously. Still 2 ranks. And I'm gonna say normal performance, because it's not really that this enhances performance. It's more so that when manufacturers don't use X8 chips, you kind of get screwed. It's not that using X8 chips means you're like pushing for more performance. It's just like you should get X8 chips, because it's usually like a good standard to keep. Like, and oftentimes you'll find most chips are X8. X16, to be real with you, I don't know how long it's existed for. I don't know how long they've been using it for. Apparently they've used it like in laptops and stuff. I don't know, but generally for DDR5, like, just please do not buy these. Stay far away. Just do not do that yourself. This is just, I'm trying not to make it too complicated, but this is just a general rule. So you have 1 whole rank on your 2x8 kit if you have X8 chips, but you don't have X8 DDR5. So if you had X8 DDR5, then this would be completely fine. But unfortunately, that's just not the case. So you're stuck with this. Well, you could have, I forgot to add this, but you could have this kit, single-sided DIMMs with 16 gigabit ICs, and this would give you 1 rank. So this is most DDR5. So Z5 with S16B, which is Samsung 16 gigabit VDI. A data with Hynix, Hynix MDI. I'm not gonna say 16 gigabit MDI, because I think you can actually have like 16 gigabit MDI and DDR4 as well, if I'm not mistaken. So I'm not gonna say it like that. Yeah, but you can't have 16 gigabit VDI on DDR4. So this is the thing. Like DDR5, this is the only time you'd ever use X16B. S16B does not exist in DDR4, so it's safe to use for DDR5 to distinguish that module, or that IC, sorry. But yeah, Hynix, MDI, these are all 1 rank kits for 2x16. Now you can get 2x32 kits. I don't know if they're 32 gigabit because I haven't owned one and I've never seen one. Well, no, you can find them. Like they do exist apparently. So this is a site that we have on South Africa. Really nice guy that owns the site. And I saw this. This is actually a thing. It's real. Like holy shit, right? So if I go to, wait, don't joke. Is it actually? Oh, it is here. I'm just blind. Oh, it's not a stock. Cool. So so yeah, I fucking found a 2x32 kit. Like holy shit, they exist. You can't buy it. This is Hynix. Oh, this is Hynix. So this is Hynix. And you can tell it's Hynix because 403939. You can tell. So this is probably not the best way to go about it, but if you wanna like get an idea of if you have, so I don't know if they bin S16B to 4800 kits. I think they do. I haven't seen one for sale. I think you can buy them from I don't know where, but they're all like these green PCB 4800 S16B kits. Fuck knows. I've not seen them. The only S16B I know of are these. So if I go to 32, so obviously these all S16B, G-Skill and Samsung have a loving relationship, as we know. These should all be S16B ICs. I don't think there's any Hynix in this. They do make Hynix, but these aren't Hynix. And then there's something else. If I find it, it's easy to find. It's overpriced. That's how you know it'll be like really expensive. Here we go. Okay, no, that's not. Wow, wow. Corsair, come on. Okay, here we go. So Corsair, generally speaking, when they make nice RAM, it's gonna cost you way too much money. So for 9,000 Rand over here, you can buy yourself a kit of Samsung S16B Corsair. It's got the DOM plat heatsink, so that's how you know it should be worth more money. Same ICs, but you have to pay more because it's Corsair, so that just makes sense, right? Yeah, so for some reason, I don't know why, but Corsair bin this particular speed bin to 1.25 volts. I can tell you right now, this will run at like 1.175 volts, probably. I don't know why the binning has been so conservative, but I mean, good. It means you're getting headroom, so that's cool. But let's go back to QVL because I'm getting on a massive tangent, but hold on. So, what did I want to show you? If I make this full, obviously you get memory socket support, so 4. So what we're looking for is 4. I think we can actually sort by this. Can we? Yes, we can. Okay, so notice something. The only kits that support 4 DIMMs, so you've got this one over here. Oh, this is not too bad. This is actually pretty good. Look at this. So you get this 4800 kit that's 34, 35, 35, 69. Not bad, not bad. Actually pretty similar to my daily. Well, the timings, but not the frequency. So this will do 4 DIMMs. This will do 4 DIMMs. This will do 4 DIMMs. These all do 4 DIMMs. Notice how literally nothing else is picked for 4 DIMMs. So, if you want a 4 DIMM kit, like you want a 4 DIMM configuration, sorry, you're gonna end up buying this at the best. And let me tell you, I don't think you can buy this because it's like nowhere. So, if you want like a really fast 4 DIMM configuration that you know should work without like a massive headache, this is about what you're getting. You're getting 5200 C38, which is not bad. I mean, it's not terrible. It's a completely fine kit. And arguably speaking, if this is dual rank, because yeah, it is dual rank because it's 4 ICs or 4 DIMMs, so this should be dual rank. And dual rank at this speed might be pretty comparable to single rank at like. I don't want to step on my own toes here, like kind of say something that doesn't make sense, but I would guess like maybe 6,000. So this is dual rank, and it's like, oh crap, man, the best I can get is a 1.25 volt 5200 kit. Like, this sucks, man. This is awful. Well, yes, but dual rank is gonna significantly boost performance. So even though it's more stressful, you can't run like 6,000 dual rank with 4 DIMMs. You know, you can't pair 2 G-Skill kits and put them in an XMP, that shit. It's not gonna work. But this is not bad. You know, you could actually potentially get something interesting done. You could probably get something like this or something like the Hynix, and maybe like, okay, first of all, these two are gonna perform extremely well. Like these two fucking garbage tier like green PCBs, if you put a fan on that shit, it's gonna perform really well. Like you're gonna get like at 1.5 volts you could scale up to like 6800, right? Like I'm no joke. Like I've seen some shit. Samsung, I mean, I I I think that there is some discrepancy between Samsung ICs right now. I think the lower tier ones do perform kind of worse than the better tier ones, but I think that these two kits are like, if you wanna run 4 DIMMs, for daily. Right now you're looking at like these two. Now I'm using this QVL because I found that this has the most like. The MSI one has some kit emissions. The Asus one has a lot of kit emissions. I think this board and the Extreme have like the best overall like variety of options. So I might go back to Asus just now. Like I guess I could do that because I have it open here, but so let's see what the Asus one does. So I want to go to. Can I even? Okay, I can. It's gonna filter. Do I search? What do I do? Okay, yeah. No, it's working. Okay, cool. Wait, no, it's not. Hello? I'm stupid. I'm sorry. Please work. Don't embarrass me. Okay, cool. Wow. Wow, that's like much variety. Damn. Like, buy this kit or else. So I mean I don't know. Yeah, I wouldn't buy that. I wouldn't buy that. I'd probably buy this or this. So search these part numbers if you want. I don't know where you're gonna find them, but my personal recommendation, if you think that I have any sort of merit to tell you what to do, I would buy one of these, because if there is headroom in your if there is Hynix spec for 4 DIMMs. So keep in mind, QVLs are only just like an idea of what you can run, because sometimes you will train other configurations that should work, but I think it's safe to assume that your best bet would be like running 4800 Hynix ICs and pairing like some really crappy Hynix kits together and trying to scale them up as far as you can, because right now Hynix but it scales like a motherfucker. And that means if you have 4 DIMMs of Hynix with this configuration, you paid not too much money, right? You paid a minimal amount of money, right? So let's say worst case scenario, you plug 2 of these kits into your system and it only does 4800. Well, it's okay because you paid for this kit. So it's like, whatever, I paid X amount of money for 4800 RAM. I can't run faster than 4800 RAM. Do you feel shafted? Not really. You feel like, whatever, it's cool. I paid for it, I got it. Like, there's no headroom, but it's fine. The world isn't ending. If you paid for something like this, and trust me, if this exists somewhere, it's expensive. Like, it's gonna be expensive. Team Group actually gives pretty decent. Oh yeah, this. Oh, no, I'm looking for this. Let's see, maybe this one. Yo, oh my word. Yo, Aorus RAM, Samsung ICs, 16 gig B die. 6600, 1.55 bin. Oh, dude, this kit's gonna cost you so much money. Like, holy shit, dude. Like, this kit right here will be so expensive. Imagine buying 2 of these kits, putting it in, and like getting 4800, bro. Oh my goodness, dude, you'll feel so stupid. Like, literally, like probably $1,000 with the RAM. I'm not even kidding. If you can get this kit for $500 in the first place, you scored. I mean, you got a pretty good deal. Like, real talk, you got a pretty good deal. If you got this kit, these beautiful aluminum heat spreaders and the fucking RGB and all that stuff, and like the beautiful Falcon logo, and it's this speed with this bin, and it's like, wow, like this cost me $500, and you buy 2 of these, and it runs at 4800, you're gonna feel stupid. So, and if you can get like 5200 out of it, you're gonna still feel stupid. After all that time, that's what you're gonna end up with. After like 20 hours of tuning, you're gonna end up in like the low 5000s. I haven't. I don't think I've heard of anyone that's run. No, I think some place online said they ran like 6000 with 2 kits. I'm just like, I just don't believe you. I just don't believe you. I don't believe it's possible. But whatever. Like, I mean, it's possible in like a vacuum. And maybe if they got sent like a god tier CPU with like the best IMC they could possibly have, like, oh, for sure. I mean, that and like maybe a Unify non-X, and you run 4 DIMMs and that shit. Like maybe a Aqua, right? An Aqua with 12 layers of PCB. Yeah, I mean, like if you get sent a god tier like SP120 IMC, like fucking just hand etched IMC, just the IMC's traces are so perfect. Like the IMC is just the most beautiful piece of silicon like that Intel have ever created. And you pair that with the Aqua, with the 12 PCB layers, and you slap on like 2 of these. There's a fucking world where it actually works, and you're gonna be like, oh, dude, it worked completely fine. Like, guys, it's fine. Like, I don't know what you're doing wrong. Like, and that's the problem with this platform, is that people just like their systems work great, and then like someone's like, oh, this doesn't work for me, and it's like, oh well, you're just doing it wrong, dude. Sorry, like you're just doing it wrong. Like there's no way. Like, it's so stupid. Whatever. Anyway, so carrying on. Okay, I've said enough about dailying stuff. So like, these are just general rules. If you want to buy 4 DIMMs, get these kits, get Hynix, try and scale that shit up, see what you get. You might get some good speeds, you might not, but you ended up not paying for it regardless, so it's fine. Yeah, this stuff, yeah, just keep this in mind. Please never forget this. It's a general rule that you always want to keep in your mind. You always want 2 ranks, but if you can't get 2 ranks, it's fine. It doesn't matter. 2 ranks is nice to have, but don't worry too much about it. Just buy the best bang for buck you can buy. Okay, so, wow, 23 minutes of literal just setting, laying the table. Okay, cool. So, how to actually overclock Alder Lake. So, how I did it. So, leave the RAM alone, first of all. Why, now, why? So, I've always advocated on DDR4 platforms, you would overclock the RAM first. So whether it be Ryzen, whether it be Comet Lake, Coffee Lake, not that I'm an authority in this, but I personally believe overclocking the RAM first makes more sense, because generally speaking, the CPU overclock shouldn't like destabilize the RAM overclock as much as a RAM overclock that's unstable to begin with will affect your blue screens when CPU overclocking, if that makes sense. And CPU overclocking generally yields more performance. So imagine you're trying to CPU overclock with like actually unstable RAM, and you're like trying to like add 100 megahertz to your core like from the factory, and you're not even getting that. And then you're trying to like, and you're just like throwing voltage at it, and that's like, what the fuck, this is not working. Like, I can't get my 1050K to 5.2 gigahertz. I can't even do 5.1. I'm barely doing 5.0. Like, what the fuck? And it's like, oh no, your RAM is unstable. Like, your 1050K is happy to do 5.2 gigahertz, but now you've just fucked it up because your RAM is not tested properly. So that's the reason why I would always advocate do your RAM first on Intel, like Comet Lake, maybe Ryzen. Just do your RAM first, because the RAM is going to destabilize your CPU OC just on the basis of you're gonna get blue screens, and then you're gonna think it's the CPU, but actually it's the RAM. Obviously, you can read the error codes, but they're not always accurate. Like, I mean, generally speaking, IRQL correlates to usually IMC or memory. Sometimes memory. With this, by the way, blanket statement, broad stroke, cache, ring, whatever, fucking fabric, dude. It doesn't matter. Like, IRQL generally means that the portion of the die that does all the weird shit is kind of like bugging out, right? Page file is generally your RAM. So, RAM, system service, same thing, IMC, all that shit. K mode exception, or K mode not handled. What is it? K mode something. Not enough VDD or VDDQ on DDR5. Surprisingly, like, this is actually a thing. I've noticed that when my RAM isn't vaulted high enough. So let's say I trained in, but like I'm not vaulted high enough. I get this a lot. Like, this is always the one that pops up. This one, this K mode exception, whatever fucking thing it is. That's the one you'll see. But these are applied to whatever platform. This one I've never seen before DDR5, and this is generally what causes it from what I've seen. So first step. So what can you cool? So can you cool 1.3 volts load voltage in LinPack? So if you can cool that, right, or whatever, you're now more or less at what I would say is a safe. That's your. So we have to keep in mind, like, your set voltage V-droops, but that's a mechanism in itself, because if you need more set voltage to prevent the dip that occurs when you set a load in your CPU, because there's a transient low before your VRM can compensate with LLC, to prevent a blue screen when you hit, like, when you do this, like, so the moment I press start on burn test, it's gonna transient down to the fucking floor, because my VRM on my poor Z690 Strix F just cannot switch fast enough to add LLC like that, like, just instantaneously. It cannot do that, and if it could, then you could theoretically run whatever the fuck you want. Like, if your VRM could, so this is an important thing to realize. If your board VRM can catch transient highs and or lows, LLC setting is redundant. It's redundant. It doesn't really matter. In a world where this is possible, your LLC wouldn't matter. So you could just do whatever you want then. Like, if in a world where your motherboard VRM is so incredibly, like, good that the moment the load releases, it just does not allow this transient high to hit like 1.7 volts and like cause gate breakdown, you could run like 1.4 volts set and like LLC fucking 7. Like, it wouldn't matter, right? Well, you wouldn't cool that because you wouldn't be able to cool like 1.42 volts at load, but like, well, depending what you have, but theoretically speaking, if you could do this, like, the LLC would be redundant and your set volts wouldn't really matter. It would be like, okay, I want to set like 1.4 volts. I want to run it like 1.35 at load. I'll do this LLC. It doesn't matter what the LLC is. It doesn't matter at what because the transient low is not going to crash me, and the transient high is not going to cause gate breakdown. So there's no consequence. Cool. But unfortunately, in the real world, especially when you own like $1,500 motherboard, and sometimes those boards themselves don't even do that efficiently because the BIOS first of all has to be written well to optimize how the power stages function. The BIOS has to have no bugs in it. There's so much things that can go wrong. It's like generally you want to stick to a very, very reasonable rule, and that is like 50 to 100 millivolts of V-droop. I think more than 100 millivolts is a bit excessive, and 50 to me is like the minimum. I wouldn't run a system with 20 millivolts of V-droop just because I think by that point you're running into that problem where your set is too low and you're going to end up blue screening under some load circumstances when you're like hitting load, and then it's going to blue screen because you V-drooped too far. And V-droop is natural, by the way, so V-droop is unavoidable. LLC is made to compensate for V-droop, so but is good. That's my general rule. So can you cool this? If you can cool this, then this is your overclocking voltage. I generally run this burn test, which uses or V2, which is Limpack 2019 instructions. I like this app. I've never used burn test, the old one and the new one, the 2019 instructions. I've never had a crash if I validated burn test properly. And same with HCI. So if I use HCI and I've validated OC on RAM, I've never had an issue unless the IMC was unstable. We'll get to that later on. It's already half an hour, so maybe I should cut this off. But so basically, like, if you can cool this, which is what this is my number. I do 1.35 set, and this V droops down to 1.3. So if you can cool this is your number, and now you want to find so if yes, maybe you could do more. Disable equals. Disable equals. And max out your P equals. So this is before we run a stress test, so just see what you can boot and like what seems more or less stable. So you could even run like 5 runs of burn test just to see how quickly it crashes if it does. So let's like you wanna identify like, do your P cores have like 5.2 in them or 5.1 in them? So, and also the ring, while you're at it, actually just add the ring, because on Alder Lake, E-cores connection to the ring, and remember, this is CPU to CPU as well. So it means some CPUs are going to have a better interconnect between the ring and the E-cores. So some people might be able to run the ring higher with the E-cores enabled than others. That's especially the case in good silicon, because some guys have silicon that does really, really good like ring while having E-cores on, and that's fucking incredible for them, but that's not the norm. It's not the standard, right? So you want to max out the ring and the P-cores. So I'm not saying run this profile daily, like run the E-cores disabled. I'm saying just see what your ring and the P-cores can do theoretically, because you want to get an idea of what you're giving up to get the E-cores higher. So enable the E-cores, and then you want to see so you might see your P-core clock drop 100 megahertz. That's pretty much normal. That's one speed bin. It's usually what happens. Some people see 2 speed bins. That's possible too. In terms of ring, you could see as much as like, I don't even, 1,000 megahertz maybe, depending how bad the effects. I mean, that's extreme, but yes, 1,000 megahertz maybe. Like if you had your ring at like 5 gigahertz, you could potentially see your ring go down to like 4,000. Really. So now you're trying to gauge like, okay, so at my max safe coolable set voltage with the LLC that I deemed best, like what can I run my P-cores at while the E-cores are active? So that's what you're gonna have to test yourself. Generally what you're gonna do is just this, and then kind of see like, okay, I add the E-cores, now I blue screen. Okay, now you know, drop the P-cores by one speed bin. Now, why does this make sense? Because it doesn't matter if, as long as like by the way, rough, but yes, like something like this, like roughly speaking. Like just max it. Why not? Like why not run the highest vCore that you can? Because there's no point not to do it. If you're running a system that you can cool at that voltage, and the voltage is within a reasonable spec range, so like Intel I think does up to 1.4 pretty safely. So as long as your voltage isn't like crazy, like you're running below 1.4, and you're running an LLC that isn't like mad, like stupid, ludicrous, like what the hell are you doing? While at that high set voltage, there's no reason not to do it. There's absolutely no reason. All that 1.4, all that max set voltage, for you, coolable, not crazy LLC, max out P cores, max out equals, max out ring, and it works because if you get the P cores in the ring to whatever, like 5.1 and 4.8 respectively, and you add the equals at that voltage and you see, oh my gosh, I blue screened, right? You bring down the ring first of all. You bring down the ring way like down to like, okay, you're gonna have to do it anyway, but you might want to test it to see just what happens. But you're gonna want to bring the ring down all the way to like 4.4. If that still crashes, like 4.0, whatever, like 3.9 even, right? So you're gonna want to see what ring kind of deficit you have to take to keep the equals enabled and not blue screen your system. You might still find instability, if not hard crashes. By that point, you know that the P cores themselves have lost the speed in due to the equals being enabled. So what you can do to prevent the equals from stealing too much, like I guess you could say power supply, you could increase L2. You could theoretically use so to compensate for the equals, you could do this, right? That might work. But generally, I wouldn't really bump this up too high. I'll show you what mine is. So I'll show you what mine is daily. My L2. My L2 is at 1.12. So 1.12. Now, theoretically speaking, you maybe get away with like 1.2 to 1.25, maybe 1.3 even. I never tested it. I can't because we haven't had this platform long enough to determine, like, if you pump 1.3 volts of L2 to get your equals up, are you gonna degrade the L2 cache? Like, I don't know. Maybe. I don't know. I could never know. I would have to do it to my own CPU and then like give you a rundown in like 2 years time. And let me tell you, I'm not keeping this for 2 years. And also, secondly, I'm not gonna fucking destroy a 12,000 rand CPU regardless. So I can't give you the answer. Like, if you wanna pump like 1.3 L2 to try and get the equals up while not sacrificing your like beautiful 5.2 P cores, then I mean, it's your system. Like, you can try. And if you want to deal with this to try and get the ring higher, while still having to deal with the fact that having this too high can destabilize your IMC, again, be my guest. It's up to you to test it. If you can test it yourself, then it's up to you. But this is like, oh, it's so finicky. My goodness. So, what do you end up with? So, what's the end result? Once you've determined how much having equals enabled has handicapped, fucking just completely handicapped your P cores in your ring, you now can start bumping up the peak cores. Oh, sorry, the equals. And again, to try and get more equal frequency, you can just do the L2 thing. I would say 1.2 to 1.25 should be pretty safe, but that's a guess. I'm not gonna try and break your system, but that's a guess. But I think it should be fine. I see no reason why it wouldn't be fine. But yeah, so once you've had these all satisfied, and now you can stress test, and if it passes, you have effectively what should be the highest safe voltage you can run with the best LLC in terms of it's not V-dripping too far, but it's not crazy, and you can cool the load voltage, but your P cores are maxed out. You can't run a higher speed bin unless you add more voltage, which you're not allowed to do. Well, you're not going to do because you're at your max voltage anyway, so you're not going to add more voltage. So whatever your P cores can do at this voltage is what they can do. Your ring is doing what it can do at that given voltage, and your E cores now, again, are doing what they can do at that given voltage. So now with your whatever your V core is, like for example mine, if I can show you, is so my personal profile, my daily is if I can find it, it's gonna be over here. So 1.35 volts set. V droops down to 1.3 under heavy load, under like burn test, at very high, and then the E cores are at 4, P cores are at 5, ring at 4. If I add more ring, I crash immediately. Even 4.1 crash, 4.2 crash, doesn't matter. No more ring. I can add more SA, but again, that's gonna fuck up the RAM, so I can't do that. That's just not. It's not free lunch. My equals 4.1, 4.2 crash. So if I add more L2, maybe I'll get like 4.2 out of them. I might try that later on. But with 5.0 P cores, I can disable these E cores at 1.35 set. I'm not getting 5.1 gigahertz on P cores. I have no idea why. I can't. E cores gone, 5.1, not happening. Not happening. So for me, this is it. 5.0, 4.0, 4.0. It's good for OCD. So whatever. Like, but that's what I'm getting. I'm not getting any better than that. And my goodness, 1.35 set is with 1.3 at load is half medical regardless. If I try and add more set voltage and lower the LLC, crash. So I've tried everything. This what I'm running right now is stable and it's rock solid. So it's what it's staying at. I'm not gonna mess with it too much. Just not with the time. I've tested everything, so that's how you would get your CPU done. So that's your CPU done, right? Now with the with RAM, I'm just gonna say like DDR4. DDR4, to be honest, is similar to how you would run other platforms, but I think that there is still some Alder Lake nuance, so this might apply to both. So first off, D4 doesn't have VDDQ. It has IVR internal TX VDDQ, but it doesn't have VDD2. So this is not a thing on D4. D4 does have so generally speaking, D4 VDDR or VDIM whatever equals TX VDDQ, but also sometimes you wanna avoid running. I think so. I think this is generally what's been going around. I think this is about the hard limit. And I think you want to keep like 1.4 to 1.5. So even 1.4 is better. But I think 1.5 should be fine. For VDD2 on D5 equals TX VDDQ. Always. So equals and VDD2 will equal as well, but with the caveat so important, very important on Asus boards. I think on MSI it's like 1.4, but I don't know. I've heard. and 1.4 for MSI. For ASRock and Gigabyte, I think it's whatever. So, yeah. Rules of thumb apply as always. So, and now this is besides the rules of thumb, but the general rules of thumb are like so for D4 S8 B die, Samsung B die, or I'm just gonna say it. BDO under 1.65 for daily. Now this is all related to cooling, but yeah, under 1.65. I would say under 1.6 for me personally, but whatever. D5 Samsung 16 GB D die. Under 1.55, but so what do I mean? If you have the 1.2 volt kit of Z5, running 1.55 daily might actually degrade your ICs. I don't know why, but I spoke to a guy, and his ICs at 1.4 volts died after 2 days. So the fact that happened means it can happen. Now, obviously, he could have had a faulty DIMM, but the fact that happened means there is precedent for it. So it could happen, and please do keep this in mind. Now, Hynix, on the other hand, I think you could probably under 1.5 volts for daily, no exception. So do what you want. Probably under 1.4 for daily. Plus the scaling is horrible. So I mean, fucking under 1.35 to be honest with you. Like, you might as well just not even do 1.4. So yeah. DJR, fuck, dude. I mean, Rev B. Again, dude, like under 1.65 volts. For daily, like 1.55 maybe. So, this is under 1.4. Hard limit. So, well, 1.45, but I would say 1.4. For safety's sake. We're not trying to break people's systems here, so. So if you own anything else besides these, don't bother. Genuinely speaking, don't bother. Like, if you own Samsung E-Die, you're probably on OCing, because it's not worth your time. If you own Samsung C-Die, it's not worth your time. If you own Samsung D-Die, what the fuck? How did you find it? How did you find it? Have you had it buried in your cupboard? Like, but I mean, Samsung D-Die, fuck it, dude. Like, I might as well put it in because it exists somewhere out there. I mean, I owned one, not too long ago. Like dual rank 16 gigabit kit, dude. Pretty sick, to be honest. But yeah, dude, 4 gigabit D-Die. Under 1.6 volts per day. I mean, dude, no, actually, D-Die, you could probably do 1.5. 1.7, sorry. So now these do not. So these stand like this stands. So if you're running any of these DDR4 DIMMs or these ICs, you can try and equal TX VDDQ, but do not push this above 1.5. Like, if you want to run DDR 1.7 volts, that's fucking fine. Do not put this at 1.7 volts. Like, do not do it. Do not do it. Like, do not. Do not do it. Please. Please don't. I beg you. If you're running D5, and you're running whatever you want to run, like this at 1.55, cool. On Asus, you're not doing more than 1.25. It's not happening. It's not happening. It's never gonna happen. On MSI, you're not doing above 1.4. It's not gonna happen. You're gonna error. You're gonna error. Like, it's gonna happen. It's inevitable. It just is what it is. It is what it is. But you can run TX VDDQ at like 1.55. That's fine. On Gigabyte you can run like VDDQ at like 1.55, but I'm not sure how much it helps. I think it helps stability. So I think theoretically speaking, Gigabyte boards might be better for like maximum overclocks. Well, the Tachyon apparently is doing really well, much better than the Apex, and I think the Unify X is doing pretty good as well. But then again, there's this rule. So, but yeah. So these are general like voltage rules for DDR5. Now, how do you actually go about the process? So, I don't have to describe this because I'm sure you all understand already. If you're gonna try and overclock that, this is what you do. But whatever max RAM voltage you're willing to gamble is not going to degrade your ICs. Plus your cooling solution. By the way, if you don't have a RAM fan, like please get one, because like just please get one. You can't run RAM at like 1.55 daily in a warm environment, even like if it's summer day or something with no RAM fan. You're gonna error. Like you're gonna error where you wouldn't have errored if the RAM ICs were running colder. So just get a RAM fan, get something, get a block. I don't care what you get, just get something. Put something there, dude. Put a fucking desk fan in your GPU. I don't care. Like do something, make it happen, because this is important. Like, train your max access latency. So like DDR4 like 4000 C14 gear 1. Like train this. So whatever you can get, like try and find your max latency. Obviously, just first thing you do, and then and obviously you're gonna loosen up the tRCD TRP timings initially, and then tighten them like once you've determined that you're pretty like you have headroom at that voltage. For whatever you've got tCAS and frequency to, obviously on DDR4 on D4 tRCD RD. So the best D5 overclocks you'll see will be like this. This is like a good D5 overclock you'll see is like this. Like Hynix, by the way, but like that. Like 28 like 1T. Daily bull, probably not, but this is what a DDR5 top end OC will look like. So with these loose ass fucking little timings, right? So, so train your max access latency, obviously, and then, obviously. So that's what we all know to be true. It's always been true. And then I can even bring in TRAS on Hynix D5 can be set to like tCAS. It doesn't matter, it knows it, it doesn't really matter, it doesn't do anything, so whatever. Samsung will be about for Samsung D5 TRAS is going to dictate tRC, which will be the limit. tRC on DDR5 or Samsung ICs is very it's a very hard wall. Like tRC is a hard fucking wall. If you hit tRC too low, you're not fucking training. Full stop. So hard wall. On Micron, I don't fucking know. I think on Micron it's like it's a similar thing. Similar rule on Micron. So I would be a dick to not give you guys like a practical use case, right? So so 64 or 6200, let's say 6200 for S16B. tCAS is as low as it can go, but let's say limits. So tRFC 450. This is gonna happen. It's not gonna be avoidable. You're not gonna really get much lower than this. So this is about what you're working with. That's about it. tRC 90, more or less. So as long as your TRP and TRAS add up to like around here, or like maybe let's say 85 to 90, like that's about what you're looking at. TRDL and TRDS. So hard limit. You're not doing 4.4. Not gonna happen. 4.6 works. T416 works too. TRTP will work about 10 to 12. This is really just stability. You could train 10, but it might not be stable. You could train 8, to be honest. It depends on what your ICs and IMs are willing to give you in terms of daily usage, but daily usability. Sorry, but basically like this is what you're looking at. TWR, fuck. I mean, anything between like 10 and 20. To be honest, like you could do anything between 10 and 20 on TWR. TWR pre, which is TWR pre minus TCWL minus 2 equals T. You're welcome. So that's how you work that out. And TCWL on DDR5 equals tCAS minus 2. So this you can expect. What else? What am I missing? Oh, TREFI. I mean, you could do 65 pretty easily. I mean, if your DIMMs heat up too far, this could literally cause your OS to just fucking disintegrate in front of you. Like a Thanos snap. Just like a Thanos snap, boot up your system and like shit just starts disappearing. Like, if your ICs overheat with tREFI too high, God help you. Like, God help you. So, this is possible on Asus boards, right? You can't do this on Gigabyte. So you can't do higher than this on Gigabyte, and I think on MSI as well. So MSI and Gigabyte are saving you because they're like, listen, don't be a hero. Take this value, be happy, and just leave it. Like, just leave it. Okay, just max it out, leave it. It's fine. It's fine. Okay, don't be trying to run 200,000. Okay, you don't have to prove yourself to anyone. It's not worth the fucking risk. Just relax. 65, 536, or 535. It's fine. Okay. And let me actually just look at my mem tweaker too. So TCKE 4 or 6 is fine. But I've seen most people run 6, so I've been using 6 because I don't know. Maybe it helps training. I don't know. Missing anything? Not really. I've given you everything. So this is what you can expect secondary wise out of S16B die. For Hynix, I think Hynix is for Hynix it's pretty similar. So remember, these are just standard things to understand. Like, these are standard like rules that just apply. But yeah, so for Hynix, we can pretty much take with us this. We could take with us this. Take with us this will work, obviously. This will work. These will apply as well. So same thing, sort of. surprisingly, Hynix, you can get away with more so than Samsung. And this applies. And missing anything? So, okay. So I'm missing something. Um, yeah. And as a result, um, so you can end up getting something like I think some users are. I think is I have to get a some sort of screenshot to give you an idea of what a Hynix OC could look like, but um, you could assume something like 28 plus 37 is often what you'll see. So a lot of them max out around there. So you could say about tRC 65 if if like tRP 37 and tRAS 28, right? So because like I said, Hynix generally template. You're gonna do something like this. Is gonna be your absolute like best case sort of where you would get the most performance at a frequency. You could do this as well, obviously. This could happen if you need to, or even you could even do like so like that. But generally, most guys on Hynix aim for like this. So they'll aim for something that looks like this. So let's say tRC could theoretically equal like 65, and then you could have tRFC actually on Hynix is also like really insane. You could do like um, tRFC will be like 250 maybe, right? Like around there. tRFC to T usually sets tRFC. On Gigabyte you set tRFC 2. So on Gigabyte you can't set tRFC 1. You set 2. On Asus you set 2. Set 1, sorry. Asus you set 1. 1 will delineate 2 and per bank. And per bank obviously wouldn't apply because you can't, well, you're not running dual rank with DDR5. So, well, most people aren't. It's not smart to, but yeah. So this is generally the rule for how you would lay it out. Tertiaries, I mean, once you've got your primary set and so whatever, like do whatever you want. Like once your primaries and your secondaries are set, so once all these are satisfied and um, you're happy, you generally are gonna just set these like slowly, just tighten them like one by one, test stability, and then if you want, you can start doing stuff like the RTLs and whatever. And by that point, like good luck to you. I couldn't be asked. It's just like so much effort. Um, but I am missing something. I have to remember one thing is generally tRFC can be tightened slightly if you reduce speedbin or frequency, and has to be increased as freq increases. But like I said, um, you at 6200, these are what you're gonna more or less see. So these are more or less what you'll get on Hynix and Samsung at this frequency is these secondaries more or less, and whatever you got for these at the voltage. And obviously, as this increases, this will increase as well, just by definition. And the same goes for tRTP. tRTP increases. Um, um, so I'm gonna leave for a bit because I'm guessing people are gonna want to look at this. But I'm gonna remove it now. So what you're gonna end up finding is that most people that get 7000 DDR5 just it just doesn't work right now on the current boards with the current IMCs we have on Alder Lake. It just for whatever reason, when you reboot, I could even say this. It's not just 7000. It's up to this. So this is hard to get daily stable. And what does daily stable mean? So there is no point to having a daily if you're gonna wake up one day, boot your computer up, boot up fucking The Witcher 2, be slaying some monsters, and all of a sudden fucking blue screen. It's like, what the fuck? There's no point. So if you're gonna want a daily DDR5, unfortunately, getting this is just not realistic. It's not even about the board or the IMC quality, it's just that this kind of speed, in terms of like rebooting the whole time and it being like rock solid, is just not common. Let me actually exclude 6400 because I believe 6400 you could get away with, but anything between this and this is not going to be daily usable. This is for benchmarks. Like this can be benchmark stable. It's not daily usable, and any sort of frequency with like good timing configuration will be a high voltage. So this is going to be 1.5 volts plus. You're not going to manage to run this daily because these are going to heat up way too fast. And with 1T good list, it increases heat as well. So anything above 1.5 for daily is just not very doable. It's just forget about it. Like, you're not going to run 1.5 daily. You're going to day like 1.4. So Borzord had a very nice video that I'll just reference because it's a good kind of video that will give you a rough idea of so if I go to fuck, did I save it? I didn't. Fuck. Okay, that's useless. But it's in Discord, so let me find that. So obviously I'm not gonna watch the video for obvious reasons, but videos. Here we go. So this video, Builds makes, is what you can expect from a daily stable, rebootable DDR5 config. And to give you an idea, this is mine. So this is what I daily, and it's rock solid. Reboot, cold boot stable. So it's 6200, 34, 35, 35, 55, 2T, 6450, 6556, 24 TWR, 12, 16, 6, 32 TCWL, and then I've got TXP4, PPD0. In terms of voltages, we've seen them, but I'll go back. 1.15 SA, 1.25 VDD2, and then that's VDD2 by the way, and then 1.35 on the RAM voltages, and 1.35 obviously on the IVR TX VDDQ. So that's my daily, and I'm happy with it. So that's what you can expect to run, right? And that's just what you're working with. To get 6600 is nice, but realistically, the situation just isn't really ideal for trying to daily it without having a massive headache. So once you have your voltages, well, no, once you have your CPU done and your RAM configured and you're ready to test that shit. Okay, so load cycle, just hit this, hit this, hit this, hit this, keep hitting it. So this load cycle 4 gigabytes, load cycle 4 gigabytes. Just keep hitting it. Hit it over and over again. So run like 15 runs, 20 runs, whatever. For like a full 5, 10, 15 minutes. So, oh, by the way, I'm a dickhead. So for let me just rule of thumb. Actually, like, yes. So believe it or not, you're gonna end up finding that your daily should have around this. So what am I saying? If your configuration has a VCCSA of 1.2 to 1.35 to 1.4, more than likely you hit that weird curve where your VCCSA will be stable. How do I know? I've tested it. So I've had VCCSA stable with my IMC at a low number and a high number. Now, the high number could actually be, like, you could big brain that shit. Ah. So, but I don't know if 1.35 daily. So, important. Like, having VCCSA too high on Alder Lake can cause system restarts and it can cause late memory errors in testing and in use. So, having this too high can cause instability, which is kind of weird. It can roll over. But when you usually see guys with these kinds of settings, generally that means that they have this system more or less like reboot stable. Once you've gotten your system to be stable in these applications with this kind of a number, you should probably be reboot stable. Probably. But you might require a little bit more, a little bit less. So VCCSA on Alder Lake is a very, very weird fucking rail. IMC VDD2 is very, very, very simple. So IMC VDD or VD2, like which is the actual name, is very simple. As close to VDD and Q as possible, while respecting the ACES and MSR rules. So that's generally what you're going to run for this, and whatever you say doesn't matter. You can Set it higher, low, whatever you want, but doesn't matter. It's cool. This one is more like fucking hell. So this one is, oh my goodness, such a headache to set. And man, like I'm telling you right now, I did so much testing, it was a fucking nightmare. What the fuck is this? Like, literally, dude, this is even, like, this is an exaggeration. Like, 1.135 is not remotely stable. 1.19 is not stable. 1.18 is not stable. Dude, it is ridiculous. And so, once you've appreciated all these, like, factors and just respected them and adhere to them, reboot that shit. Test again. If fail on the restart test, start tweaking again. So again, and whatever number you're at is probably and if pass on restart, drain power, cold boot, try again. If this all passes, congratulations, dude. Wee. So, like, it's that bad. I'm not even kidding. It's that bad. Yeah, I mean. So, once all this is done. So, this will be about 500 to 1000% coverage. I think for this you use like, I think it's called anti-extreme or absolute, whatever profile. Karu is like, what isn't it, like 10, like 7,000%? I think it is. So yeah, 7 to 10,000%. I think it is. Good luck. If this all passes, if CPU maxed with max voltage and IBT v2 OCCT slash P95 if you're a crazy person, then cool. If IMC passed all that shit, then cool. If memory did an error, then cool. Do not remove or okay, so if that's all respected, so if you did all this shit, I'll call you daily stable. Like, that's daily stable. That's, you're not gonna crash running any game, any app, any use in your computer. You're not gonna crash doing anything, work, whatever. You have mastered Alder Lake, so congratulations. I hope this helped. I think it's, I hope it's helpful, but that's pretty much what I've found, and yeah, so yeah. Cheers.